Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we review area. So remember, area is the amount of 2D space that can fit inside a shape. So it's measured in square units: millimeters squared, centimeters squared, meters squared, and kilometers squared. So sometimes you are going to be asked to convert between these units, and people always mess this up. You see, most people know, for example, that there are 10 millimeters in a centimeter. But there are 10 squared or 100 square millimeters in a square centimeter. There are 100 centimeters in a meter, but 100 squared or 10,000 square centimeters in a square meter. And same here, there's 1,000 squared or 1,000,000 square meters in a square kilometer. So when you're converting from a smaller unit to a larger unit, you divide. It sort of may seem a bit counterintuitive. You might think larger unit, if you're going to a larger unit, you must times. But there are fewer of the larger unit, that's why we divide. So if you want to go from centimeter squared to meter squared, you divide not by 100, but by 100 squared. If you're going the other way, the conversion factor is still the same. So it's still 10 squared, 100 squared, and 1,000 squared. But instead of dividing, you times. If you're going from a larger to a smaller unit, you times, because there are more of the smaller unit. So let's say you're asked to convert 0.32 meters squared to centimeters squared. Well, most people, they just times by 100. But you can't do that. If you're going meters squared to centimeters squared, you need to times by 100 squared. There are actually 3,200 centimeters squared in 0.32 meters squared. So how did I get this number? On my calculator, I just put 0.32 times 100 squared. I don't square this number, I only square the conversion factor. So let's say I wanted to convert millimeters squared to centimeters squared. A lot of people would make the mistake here, they'd only divide by 10. But if you're going millimeter squared to centimeter squared, you need to divide by 10 squared. You need to divide by 100 because there are 100 square millimeters in 1 square centimeter. So sometimes you'll also be asked to convert with hectares. So a hectare is actually 100 meters by 100 meters. Now a hectare, you'll notice, doesn't have the little square on it because it's already a square unit. So that's what 1 hectare is. So there are 10,000 square meters in a hectare. So just as before, if I'm going from a smaller unit to a larger unit, a hectare is much bigger than a square meter. So smaller to larger you divide, and larger to smaller you times. So because of the way the conversions work, there will be 100 hectares in a kilometer squared. A kilometer squared is much bigger than a hectare. So if I want to go from hectares to kilometers squared, I divide by 100. Kilometers squared to hectares go the other way. So for example, if you have 34 hectares, that will be divide by 100, 0.34 kilometers squared. If I want to convert 34 hectares into meters squared, I would times by 10,000. So it would actually be 340,000 meters squared. Okay, so how do we actually calculate area now that we're good with units? So in order to calculate area, we need to be able to identify the shape and use the right formula. So your notes have all the formula, and I won't go through an example with every shape, but let's start with this one, a triangle. So the formula for the area of a triangle is base times height divided by 2. Whenever we use h in a formula, in measurement, we mean perpendicular height. So h is this height here, this is the base 8. Now sometimes you will need to use Pythagoras to find an unknown side, and that's what we'll need to do here. So remember, for Pythagoras, if you're finding a shorter side, you can use the formula here, a equals the square root of c squared minus b squared. So remember, for Pythagoras, c is the longer side, the hypotenuse. So here, if I call this h, the perpendicular height, So it's just going to be h equals square root of longer side squared minus shorter side squared. So putting that straight on the calculator gives me 6 meters. So now that I've found that, the area is just going to be base times perpendicular height divided by 2. And of course that here will give me 24 meters squared. So this second shape here is one that tends to cause a lot of problems. So it's a 4-sided shape with one pair of parallel sides. It is a trapezium. So a trapezium has a complicated formula. Its formula is area equals, again we have a h, which means perpendicular height, over 2 times a plus b. So a and b are the two parallel sides. So here, I don't actually know the perpendicular height. I need to use Pythagoras again. So I'm going to call this h. If it's 20 along here and 15 along here, then it must be 5 along here. So here, h will be the square root using Pythagoras of 13 squared minus 5 squared, which gives me 12 meters. So that means the area will be perpendicular height over 2 times the sum of the two parallel sides. So it's 35 times 6, 210 meters squared. So that's all for area. Just make sure you follow the formula closely. For example, when doing kites, you have to divide by 2. People often forget that. But let's now look at finding an unknown side when you already know the area. So in each of these diagrams, we're given the area and we're going to find a dimension. We're going to find x in both cases. So let's look at this shape here. First, we have to identify the shape. Well, it's a 4-sided shape. All 4 sides are equal. It must be a rhombus, and a rhombus is a type of kite. We can't be sure it's a square. It's not going to be a square because a square would have 4 right angles, and this doesn't. So this is a kite. A rhombus is a type of kite. We're going to use the area formula for a kite. So the area formula of a kite is half times xy. X and y are the two diagonals. So here we can just change y, one of the diagonals, to 12. And we're told that the area is 48. Now we need to solve this equation. So making it a bit easier to work with, a half times 12 is 6. We get 48 equals 6x, divide by 6, x is 8. It's a unit of length, so it'll be in meters. Okay, and that makes sense because if I had 12 and 8, the area would be 12 times 8, which is 96, divided by 2, which gives me 48. All right, this second example, we're using a trapezium now. So the formula for the area of a trapezium, the area equals perpendicular height over 2 times the sum of the two parallel sides, just like we did on the previous slide. So here I'm told area is 160. So we're following the same process as last time. Anytime you're told the area and need to find a side, you just substitute into the formula everything you know, and we're going to rearrange to find the thing I don't know. So making this a little easy to work with, 8 over 2 is just 4. So now I solve this equation. I'm going to divide each side by 4 to get rid of this 4 here. And now I'm going to subtract 22 from both sides. So x equals 18. Of course, once again, we're in meters. And it's as easy as that. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.